Hey there, I'm Mike Peel, your host of the Full Crew. We're excited to be talking about R&D today. We've got some great articles that are coming up, including a U.S. firm in the Ukraine is promising a tool that can get around GPS jammers, which has been a big issue over there. Um, some AI swarm stuff, but in tough environments. So the evolution of that UAS technology. And we've got a new rule from the FAA to discuss, which is always a big topic with our audience, being that we started as drone people, but we are also AAM and general automation people now. So we've got some great guests to talk about these topics today. I'm going to start clockwise with Mark. Mark, introduce yourself.
Well, good morning, and I guess good afternoon, or soon to be afternoon for me. My name is Mark Genung. I'm the head of flight operations for the Nevada U.S. test site. I'm a commercially rated UAV pilot as well as a private pilot. I've been in 3 startups, everything from precision infrastructure inspection to drone delivery to research and development of machine vision technology for detect and avoid. It's great to be here. Thank you.
Yeah, happy to have you. One of our super fans, always in the chat on our other shows, and this one as well. Really nice to meet you in person. And then we've got a return guest, Chris Corgnati, who's now at FIXAR. So Chris, tell us a little bit about what you're doing and why you're here.
Sure. Yeah. Chris Corgnati, like I said, a retired Navy captain. I was a P3 Navy flight officer in my former life, and about 12 years or so now in the drone industry on my 3rd startup, and I'm on the board of directors at FIXAR Global. And so happy to be back.
Yeah, happy to have you back. And then also we've got Mike over here. So Mike, tell us a little bit about yourself.
Yeah, so I'm Mike Hirschberg. I'm the Director of Strategy for the Vertical Flight Society. That's a nonprofit educational technical society. We started in 1943 as the American Helicopter Society, but there's a lot more vertical flight things than just helicopters these days, right? So drones, advanced air mobility or electric VTOL, helicopters, advanced rotorcraft. So we try to cover them all. From the technical perspective, and we have conferences and lots of publications and stuff to help people understand the technology and help to advance it, and working across the board with different organizations and companies and government organizations, and not just vertical flight. Although we changed the name to the Vertical Flight Society, we're big into electric flight, hydrogen flight, hydrogen electric, hybrid electric, and stuff like that. So. I was the director for the executive director for the society for 12 years, and last year and a half I've stepped down to be the director of strategy to do more fun things like this.
Well, thank you. Nice to have you. You work with Rex, is that correct?
Rex Alexander, right? He's our infrastructure advisor and all around great guy.
Yeah, Rex has been a guest a couple times. I always learn something on a Rex episode.
Me too.
Me too. I'm sure I'll learn something from you today. I just want to give a quick shout out to our sponsors, of which we have 8 today. So lots of support from the community. The show is doing good and growing. So I want to thank Arium Analytics, True Weather Solutions, Grand Sky, Clarify Consulting, UAS Strategic, Metis Technology Solutions, Airspace Link, and End State Solutions. Thank you for your support for making this show possible, and a lot of other shows on the Dawn of Autonomy, or now Global Autonomy Network. So let's get started on our first article. We're going to be, I think, starting with Chris's, if I remember correctly. And so swarms, AI in tough environments, the evolution of UAS technology. So, Chris, why did you pick this article, and what did you think was important about it?
So I picked it because it actually just got me thinking in a broader sense. The article itself talks about the use of AI and swarms in Ukraine. I think primarily would apply to Gaza to some extent as well. But being this is dual use month, I started thinking, okay, how does that apply beyond just the military applications? It does allude to critical infrastructure protection here. So domestically, obviously, if you can use it to attack a military target overseas, someone could use the same technology against critical infrastructure. So, I think there's a piece of it that we need to look at from the defense standpoint here, and that was addressed somewhat in the article as well. But on the dual use side, I started thinking about what else could we use those technologies for, and how's it being used. And one of the interesting questions, everybody's talking about AI, right? Swarms kind of defined, right? Multiple aircraft, one control or coordinating amongst themselves to do an action. AI gets thrown around, and it reminds me of our, autonomy versus automation discussions from like 15 years ago. Everybody's like, oh, everything's autonomous. And we'd be like, no, it's not. It's heavily automated. It's not autonomous. Now we're getting there. And I think AI is being used the way we use that term. And people are using artificial intelligence, and it is being, and even at FIXAR, we're incorporating it into our products and increasing our capabilities through AI. But it's, I always take pause when you start reading all of the, the press releases and the articles about everybody's AI. Like, okay, well, what do you actually do, and what are you trying to accomplish, and how are you going about it? And so those are important questions, really, to get, I think, credibility and trust and confidence in the technology. And we'll talk about safety and the FAA, I think, later in the discussion. But all those things play into it, right? If you really have to understand the technology, how it's being employed, and how is that going to then impact us in the safety realm. The second thing that it spurred in my head when we talk about dual use is, to me, to scale commercially with UAS, especially in the United States, if you could do two things: fly beyond visual line of sight, which we'll talk about with regulations, and the second is you can go one to many on the control. So if I can have one operator and multiple or many aircraft, or potentially a swarm, now you can start making business cases where you can actually make money doing this kind of stuff at scale. I think those are the two biggest impediments, because, take it one step further. What if I could take a swarm in an agriculture environment, right? And I could survey, do multispectral, analyze the problem, and do, targeted applications of pesticides or fertilizer, whatever you needed in that. If you could do it all in one swoop, one operator, multiple vehicles, or in a mapping LiDAR scenario, I could do a much larger area with multiple aircraft very quickly. Again, it's much more economical, right? I deploy to the field once, I get all of the data over a large area that I need, then I go back and I can analyze it, instead of having somebody out there for a week flying one aircraft at a time, collecting little bits of data. So that's sort of why that one just kind of caught my eye and said, AI and swarm being used in war, but in dual use month here on the show that we're talking about, maybe there's another angle to discuss.
So one of the things that's interesting about swarms, or just the discussion of swarms, is I think there's a lot of interpretation that the drones are communicating a lot with each other, whereas most swarm technology that's actually implemented today is the drones working independently from each other, and it's all coming from the ground control station. So I'm curious to see what advancements we'll have in computer vision that'll help that out. But I do want to note that, like you said, AI. I think part of like the hesitancy to just glom onto any AI headline these days is what type of AI is really the question, right? Most people associate it with LLMs, which I'm now really just calling compressed word searches. They're thinking of them as intelligence almost offends me now that I know exactly how the technology works. Whereas computer vision is actually increasing in reliability in a way that actually does feel like intelligence or intelligence analogous technology. So who wants to go first? Mike? Mark?
Well, certainly on the machine vision side, I had a great deal of experience with R&D for that, with a company formerly known as Iris Automation, doing it as an onboard detect and avoid technology, as well as a ground-based system. They recently got bought up by UAVionics. They still offer that product, Cassia. And you're exactly right. It provides great promise and great flexibility to be able to integrate AI with those camera systems. We were dealing with everything from having dragonflies get in the field of view of a ground control station, and the system would say, "Oh, that's an aircraft," because apparently it has a fuselage and a wing and things like that. And so we had to train the system on what a dragonfly was versus, say, a Cessna. So it shows incredible promise that there's a lot of effort up front. We did something like 15,000 intercepts to get the kinds of data to get a reliable system like that. But I think you're exactly right. Machine vision, I think, is going to be key to much of this, especially in a swarm world, where then you can potentially more clearly interact. When you watch how birds fly in a flock, they're basically using their ability to see other birds and maneuver without colliding with each other, and still provide a distraction to maybe a predator, or be able to fly safely from one side to the other. So yeah, I really appreciated the conversation, but there's different flavors of AI. I do agree with you that machine vision is a wonderful example of some of the really cutting edge kind of things to that, and I do think it provides ultimately the kinds of flexibility we're going to need, not only for in using swarm, if you will, for business, but even swarm and counter UAS. One can imagine launching a swarm to defeat something that, where if the first aircraft misses, the second one can make a correction based upon the lessons learned from the first one, and potentially get a skin to skin or some sort of equivalent kind of means for disabling something that's coming in. So yeah, I see a bright future for these tech.
Yeah, I've seen multiple different ways of handling swarming that are interesting. One is like a mothership model, where basically there's a lead car, essentially, and the others are waiting for signals from that, which might actually be useful in, you could have a couple of motherships with swarms for counter UAS that could handle kinetic solution there. The other thing is kind of like a mesh network type of thing, but the problem with every time you do that is you're increasing the amount of computation, and on drones, you're very limited in how much power resources you have. That's why we always target low swap devices. Any feedback on what Mark had to say, Chris, before we go to Mike?
No, I mean, I think it's a good example. As we were talking, you were talking about how the vehicles communicate, and maybe there's some analogies to how people are envisioning automated driving working, right, on an automated highway. Are the vehicles going vehicle to vehicle, or is there a central point that's broadcasting data that all the vehicles then suck in and make the decisions based on that? So there may be some analogies there. Just kind of a little bit of a tangent, but a similar environment.
I'll go.
Yeah, I mean,
Sorry. So we had a little bit of a discussion before we kicked off about the UCAV program and naval UCAS. So in the early 2000s, I worked at DARPA, the Defense Advanced Research Projects Agency. We had a joint program with the Air Force for the Air Force unmanned combat air vehicle, and then the Navy, and then they got combined into the joint UCAS program. And at that point, I'm not a small drone guy. I'm a big drone, a big airplane guy. So those were 50,000 pounds, intercontinental, stealth bombers, robotic bombers. So they had tons of onboard computing power. But the idea was you would have one operator controlling 4 aircraft, and it would be using satellite communication. So you couldn't live with the latency of having the ground control system being communicating, so the 4 aircraft had to communicate amongst themselves and collaborate. And this is before the word AI had been invented, but they would collaborate and then send back a picture saying, hey, I think this is a tank, approval to kill it, and you hit yes or whatever. But so I mean, there's different ways to do it, and I think some of the points that have been brought out here about the dual use. That's obviously not a dual use, but when you're doing agricultural environments where you're in you're in line of sight or pretty close, those types of feedbacks with the ground station or other means like that, I think obviously that's much cheaper than to put all the onboard computing power on the aircraft.
Yeah, it's really dependent on how much latency you could afford, right? And then also, I think one of the ways that actually systems that are closer to an LLM in design might function at some point positively in this respect is determining who's the leader when, like what situation warrants the ground control station being in charge versus maybe a drone that is identifying something that warrants communication to the other drones and then taking precedent, right? So that's something I'm kind of looking forward to, but I don't expect much other than research to be done on that front for the next couple of years. Any other comments before we move on to the next article?
Yeah, good. Thank you.
All right. Yeah. Looks like we covered that one pretty good. Next up is, I believe, Mark's. We're talking about GPS jammers in the Ukraine and how to get around them. So, Mark, tell us about your article and what you found interesting about it.
Well, I was attracted to the article on a number of levels. One, of course, is as the human condition is that combat is oftentimes the crucible where necessity is the mother of invention. And I'm also always interested in R&D where you take an existing technology and potentially use it in a new manner. I did that in my active military experience with being able to use Aegis fire control radars to track ballistic missiles, to new weapon systems I put on board the ship, and realized that the infrared sensor on there was great for doing search and rescue. In this case, this company Zephyr is using smartphones to better understand the electronic warfare environment. It's almost a parallel to what True Weather is doing with regards to a number of microstations in a given area to understand the weather environmentals, understanding the electronic warfare environmentals, which will change position to position based upon shielding from buildings, the source, the kind of jamming, those kind of things, is a really effective means for the Ukrainians to understand how to better employ their weapon systems or potentially use more sophisticated systems where I have a bigger risk due to electronic warfare versus other places where I could use an easier solution. So in many of the same ways where we potentially use joint strike fighters against a more advanced air defense system versus legacy F-18s where they can operate in a less riskier environment. So I like that fact. And there was another article that I almost showed as well, which was the Ukrainians using acoustic sensors on smartphones that they mount on poles, distribute them throughout the area, and doing acoustic analysis to be able to detect everything from drones to tactical aircraft. We had considered doing something similar at a previous company for optical, basically distributing smartphones in that manner. And I like this idea because when you think in terms of a smartphone, it's got a number of sensors integrated in it: optical, acoustic, accelerometers. It has a built-in compute power capability. It has a built-in link capability to be able to report things and report data. I just like this a lot because it showed the value of how you could potentially, again, taking legacy technology, use it in a new manner to solve a problem in a really price-effective way. So that was fundamentally what I was drawn to on this. And electronic warfare is already hard enough. I think we've all seen the articles about systems that have been deployed to Ukraine that have not performed as well because they're part designed to operate in a non-GPS degraded environment, and so we've had to learn a lot, and we've even seen systems that have. There's open press reports of how we sent systems over who were designed to work in GPS denied environments, where the Russians have learned workarounds to prevent the systems to be not nearly as effective 1 or 2 months later after these systems are deployed. So this is an ongoing, castle versus the cannon kind of thing. And like I said, I think it's a really important topic in terms of electronic warfare, and it's a new use of legacy technology to solve a problem in a distributed and relatively inexpensive manner. So that's what attracted me about this.
Yeah, it's certainly really cool. And also one of the things just in general, bringing it outside of the context of Ukraine is just not having to completely rely on GPS anymore. It's a foundational technology for the last 30 years in terms of commercial consumer use. It exploded, and we're not putting less satellites in the sky, but we're also seeing the risk of being super reliant on these systems now and looking for alternatives when we can, at least so that we have fail safes and backups when they fail.
Well,
So
we're back to the future.
Yeah.
The old Tomahawk missile systems when I first worked with them in the 1980s, basically used a Turcom kind of a camera system where as it flew over different waypoints, it would take an image, it would compare it to an image that it carried on board, and would update its position based upon that. We shifted fundamentally to GPS because the inherent advantages of GPS over time, but now we're back to the future. Visual odometry is, I think, going to be a key technology. Is going to continue to improve those visual engines that have been described by near Earth autonomy, and I think even Iris Automation. We were talking a bit about that at conferences. I think is going to be those key enabling technologies because I think GPS is no longer assured anymore.
Yeah, absolutely. It's very much a Red Queen situation where the evolution always happens. So like whatever you think the expectation of the technology dominating, especially in the battlefield in the Ukraine right now, I heard the optimistic outlook for any technology deployed is 6 months before the adversary is able to adopt it or move around it. So certainly a different type of war that we're learning lots of lessons from here. Mike, what are your thoughts?
Yeah, I mean, definitely, whatever countermeasure there is, there's a countermeasure, or whatever the Russians try, then the Ukrainians figure out a way to defeat it, and vice versa. I mean, that's the nature of warfare in general, and you're just seeing it here more, I'll say, on the low tech perspective, because this is just, I mean, it's almost like World War I with the trench warfare, where there's very little gains, and so you're kind of doing the same thing. It's not like they're covering thousands of miles of conquered territory or things like that. So you're kind of doing the same thing day in and day out. So these new technologies, or these new solutions that are being tried, when they're successful, then the adversary comes up with a counter to it. One thing is a little bit of a tangent, but it really got me thinking when I was reading this article about cell phones and Ukraine. So the technology for the Ukrainians now versus 10 years ago, when Russia invaded the Crimea and captured that area, is just really amazing. Besides drones and just, the U.S. provided all kinds of, modern warfare technologies and training and things over the last 10 years. So I think the Russians thought that, like they marched into Crimea, they would be marching into Kiev within hours or days at least. And it didn't turn out that way. And again, you see this, this measure and countermeasure approach. And again, a bit of a tangent, but cell phones in Ukraine. So one of the reasons why Russia was able to march into Crimea 10 years ago was because of Edward Snowden. So this is a great book. Let's see if I can do it. I think it's in focus. Yeah. Anyway, they talk about how you can see they talk about how in the 2013 timeframe, he came out and said, "Oh, the Americans were spying on leaders like Angela Merkel, the Prime Minister of or the Chancellor of Germany," and it created all this hubbub and mistrust and things between the U.S. and allies, and so everyone was consumed with that instead of watching what Russia was doing on the Ukrainian border. Turned out, they were never. There was never any evidence found that the U.S. was actually spying on them. Maybe they were, or maybe they weren't. But it was a diversionary tactic of dividing the allies and allowing Russia to march in. And I think that there's a little bit of that before the Russian invasion of Ukraine this time as well, where there was a lot of back and forth. But technologies like using innovative use of, I'll say, not advanced technology, right? You're using off-the-shelf cell phones or off-the-shelf drones, or making your own drones to gain advantage. I think is something that's really been eye-opening in this this conflict over the last year and a half.
Yeah, I think the distinction is the level of improvisation that was required by both sides, but more so the Ukrainians. I mean, some of their drones, many of their drones are 3D printed,
Right.
but
Right.
they're getting the job done. So like,
Yeah.
who's going to complain?
Yeah.
And
No, absolutely. It's been really amazing.
And I think one of the points that Mark is kind of hitting on is what is old is new again, as some of our mutable systems, anything related to technology that can be interfered with, cloned, or spoofed, is now actually less relied upon. Like the assumption that technology is going to work when you need it in the trench is not there anymore. Whereas in previous conflicts not that long ago, it might have been. Chris, any feedback?
Yeah, I mean, it kind of sort of reminds me of almost some, passive radar technologies, right? Where if you can sample an environment and understand the electromagnetic spectrum, and then you can detect anomalies from that, you can gain a lot of information. You don't have to have exquisite active sensors all the time. If you can sample the environment with lots of cell phones and figure out what's new and different, triangulate that. I think there's a little bit of an analogy there. And then going back to my anti-submarine warfare days, when you're sampling the ocean environment and all of a sudden you expect to hear something or see something and you don't, that's a piece of information also, because we used to have some pretty good submarines on our side, and some other folks as well. And sometimes you're looking for them and you go, wait a second, there should be a lot more noise over here. That's important. So if you can sample an environment, electromagnetic or acoustic, and start to look for those anomalies, you can, again, with pretty cheap sensors and older technology, do some interesting things. So I think that's sort of analogous to what they're doing there.
Yeah, complexity doesn't necessarily mean better. It just means sometimes more nuanced information.
Right.
But it also, usually with complexity, failure rates increase, right? And that ultimately is what defines true innovations versus just whatever the interest of the day because it does something cool. The gimmick are usually defined against that line of reliability. If it works well enough with the least amount of complexity, Occam's razor there, it's usually a technology that's going to stand the test of time.
Okay.
Any last thoughts, Mark, on your article before we move on?
No, like I said, I think my intuitive sense is that I think a lot of folks are going to take a harder look at like smartphones and how they can potentially use in a distributed manner. And I think I think this is in many ways kind of the pointy end of the spear and how those kind of technology to be used, because when you think about it, the processing and the communications, all the sensors on board, what a great way to understand an environment in a variety of modalities.
Yeah, absolutely. I mean, it's technically the most affordable portable computer, right? Generalized computer.
There's far more computing power in my phone than in the airplanes that I first started flying when I joined the Navy. By a good margin.
Yeah,
Sorry, it's basically the realization of the Star Trek tricorder, right? I mean, the stuff that they had in the '60s. I mean, that's what these bricks are today. It's tricorders are amazing.
Yeah. So the story goes that there's more computing power in your phone than there was on the Apollo missions. So,
Space shuttle.
Yeah, I mean, it was a space shuttle. Wow. So we're talking much later then too. Yeah, I mean, given how long Moore's law was able to actually last in terms of manufacturing, the chip size getting smaller over time or halving every 2 years. Before now, that was a given that was going to happen. So it's hard to even like kind of conceive the exponential line, what that really feels like in terms of the power we have. And in some cases, because we were growing so fast, we didn't optimize the use of all that power. And what I've been seeing, especially in the drone space, given the constraints of the technology, in terms of resources like power, especially, is now we are fighting that optimization battle. How do we squeeze this out of that? And I think it's interesting. I think you're seeing, especially with this, is a retroactive look on technologies that already exist to see what we could get out of them, which is kind of cool. Going to take a quick break just to thank our sponsors again. I'm going to pull them up because there's so many. I'm really happy that we're getting so much more support these days. So just quick thanks to Arium Analytics, True Weather Solutions, Grand Sky, Clarify Consulting, UAS Strategic, Metis Technology Solutions, Airspace Link, and State Solutions. We thank you again for making this episode possible. And there's a lot of names on there that have been with us for years. So it's nice to see both a mix of old and new continuing as we grow. All right, so the final article is Mike's, and we're going to be talking about a new FAA rule, which is actually always one of our favorite topics to cover here. So Mike, tell us a little bit about this new rule and the future of air travel.
Yeah, thanks. So, I mentioned Vertical Flight Society. We're a technology organization. We don't do that much with regulations per se. We really support other organizations like GAMA, NBAA, and others who really do the engagement with the regulators. But from the technical perspective, we held the world's first eVTOL conference workshop in 2014, so 10 years ago. We saw the writing was on the wall that all these new technologies that have been so well developed in the drone world and the UAS world were at the cusp of able to be scaled up for passenger carrying and cargo carrying large aircraft using either battery electric, hydrogen electric, hybrid electric. It's really focused on battery electric in the early years. Uber announced their Uber Elevate initiative at one of our conferences, our third annual conference actually in 2016. And we've continued to grow throughout the years, supporting this burgeoning advanced air mobility industry. Advanced air mobility also includes, small UAS and things like that. But when I say I'm really talking more of the larger, 1,000-pound, multi-1,000-pound aircraft. So the FAA came out with their Part 23 is a regulation that regulates small aircraft. They came out with Amendment 64. I think it was in 2017. I can't remember the year. Sorry, but it had in there basically the idea, which is what the eVTOL industry had assumed, basically what the FAA was saying, was that they would treat these aircraft like airplanes. They're gonna be just like a Cessna. They're horizontal they're just like a regular fixed wing aircraft, except that they have special conditions for vertical takeoff and landing, hovering and things like that. So in 2022, May of 2022, it came out that the FAA decided that no, they weren't airplanes, they weren't helicopters. They were going to treat them like powered lift aircraft. They're going to treat them as powered lift aircraft, which the FAA had never developed before. They're going to use a special class called powered lift. If you're interested, it's Part 2117B for basically if there's not already existing regulations for something. You can take, you can take some things from Part 23, 25 for airliners, small and large helicopters, Part 27, 29, and you can, kind of mix and match to have a basis for certification. So with this change in May 2022, everyone's like, okay, instead of using this known path that we thought we're going to use, the FAA and industry kind of had to start over. I mean, a lot of work had been done already, a lot of flight testing, a lot of development. but they decided they're going to just powered lift things. So they came out with different airworthiness requirements for Joby and Archer. To those are the two leading companies. And then in June of 2023, so a little over a year ago, they came out with this FIXAR, which was a special federal aviation regulation, which handled how to train pilots and how to operate aircraft. So, there's all these different kinds of approvals you need for a human carrying or large aircraft, or a type certification. There's airworthiness, there's a production certification, and then there's operating rules. So there weren't any operating rules for how these aircraft are supposed to be operated. So the FAA came out with this in June of 2023, and at the draft, and it was not good. I mean, it was sort of a Frankenstein document. It looked like every office in the FAA got to put their 2 cents in it. Airports and flight standards, everybody said, we don't know anything about these aircraft, so therefore we got to make the rules very, very conservative. So the industry, again, basically almost every 4-letter or 3-letter acronym association, AUVSI and AIA and VAI, everybody really came together and said, no, these are our comments, these are our suggestions, and the final rule then came out last Tuesday, so a week ago and an hour and a half ago, 10 a.m. Eastern. Came out with these rules. So in this article, it's the administrator of the FAA speaking about this new document, and the actual name of the document is so the first one is called SFAR, the Special Acquisition in DoD it's acquisition, but in FAA it's aviation regulation. So it's actually called this. Integration of powered lift, pilot certification operations, miscellaneous amendments related to rotorcraft and airplanes. It includes the special federal aviation regulation in it, but there's also some for a period of 10 years to figure out, make sure these are the right rules. But it also includes a number of permanent changes. So basically the industry is still looking at it. It's 880 pages. There's some meetings, some multi-association meetings that are happening this week to do deep dives into this document to go through everything. But really, the initial impressions are the FAA. Again, initial impressions, top level. The FAA got it right. So they listened to the feedback from all the associations, and they made a lot of really important changes. And I can go into these, but I just wanted to highlight one statement in this rule. Actually, wasn't in the it's actually not this. Sorry, it's actually not this. Here it is. There was a blog post. Actually, was the one I wanted to talk about. But it's Mike Whitaker came out with this, the FAA administrator, and he had a key statement. He says, he said, our work reflects one of my maxims: always put safety first, but support innovation to the maximum degree possible. And that statement from the FAA administrator is exactly the same as everybody is trying to give birth to this new industry of having these new types of aircraft. Nobody wants to have an accident. Like, these aircraft are supposed to be, 1,000 times safer than general aviation airplanes and helicopters. These are intended to be very, very safe. So we don't want to rush it. We don't want to take any shortcuts. We don't want to do anything dumb, but we want to allow innovation to develop slowly and in a predictable, well understood path, so that nobody's going to have 1 million or 1,000 of these aircraft flying tomorrow or next year. It's going to be a process of developing these new aircraft, testing them, doing pilot operations, and then scaling them up. So that's I'll stop there, but that's what I wanted to do as sort of an introduction to this these new regulations, because the industry has been developing these aircraft for 10, 15 years in some cases, flying thousands of flights, making these aircraft both from a theoretical safety perspective and also an empirical perspective of actually testing the aircraft in all these different cases to ensure that when they do reach the public for operations, that they are as safe as they possibly can be, and they will continue to be safer and safer as the operations develop.
So what defines these aircraft different than traditional helicopters, and what are the limitations of this rule? Because as far as I know, talking about the automated versus autonomy dichotomy from earlier, this is more on the automated side still, correct?
Right. So pretty much all these aircraft are fly-by-wire. Okay, so the pilot makes inputs, and then the computer tells all the different control effectors and the motors and the flaps and everything what to do. That's different than any civil helicopter today, almost any civil, general aviation aircraft. Almost every aircraft still uses mechanical control. So when you push the lever forward, then there's levers and there's connectors that actually mechanically link things together. And a pilot can has the pedals, they can control the power and flap angles, stuff like that. They can do that manually. But with these new aircraft where they have 6, 8, 10, 12 different electric motors, they've got all different kind, you can change pitch angle, you can change the rotational speed, all these different things. It's more complex than a human could do. So you need the computer controls to control all these things. And with that automation, and again, not autonomy, but automation, then you can have a much safer aircraft, because the computer can decide what you're trying to do is not safe, right? So you can build in more safety by having more things automated.
But
If that
it's
helps.
more complex, right? So that's
It
why
is more.
you need more rules,
Yes.
right? So like you don't want to end up in a 737 situation, right, where the compensation to the user is actually potentially causing a problem in the future.
Exactly right.
So Mark, any feedback on this?
Well, no, I think I do appreciate the fact the FAA listened, and I appreciated the administrator's comments. And quite frankly, I think we're seeing a little bit of a maybe groundswell when you look at the language that the FAA has briefed that they're quote unquote considering for Part 108. It's incredibly responsive to what the industry put together as part of the Beyond Visual Line of Sight ARC report. So there does seem to be more of an understanding to be able to move the industry forward with safety first in place, but also an understanding that not an one size fits all kind of approach as well, especially for Part 108. So I'm really happy when I skim read this. I came to the same conclusion. But VTOL is hard. I mean, DoD has been flying VTOL aircraft, the MV-22 Osprey. That aircraft has had its challenges. It continues to have challenges. There was about a 6-month period when that aircraft was down across DoD because of some issues where they found a complex part that it either failed because of poor engineering or potentially poor manufacturing. And these are the kind of things that, while you accept a certain amount of a level of risk within DoD, you minimize that to the maximum possible to get the capabilities out of that. It is, as was earlier suggested, we're on general aviation. We want to drive those kind of things down to 10 to the minus a really big number.
Yeah, Six Sigma versus Andy Thurling once told me that the military might tolerate 70% success rate, but the general public will only tolerate 6 Sigma level of failure.
Yep, and we'll oftentimes mitigate that everything from aviation and nuclear power by the dependency of really highly trained people with operating against validated and proven standard operating procedures. And in this case, we're trying to shift to again that autonomy approach that you may not have that level of training or could afford that kind of level of training to make a business that works. So your higher dependency on the automation has been alluded to. So Yeah, I applaud it. I think it reflects a groundswell we're seeing out of the FAA in terms of some of the regulatory approaches they're taking. And the Lilium filing for insolvency overnight, where that just shows that this was an aircraft that was designed, presumably, I think I saw spread something that was designed for a 750 watt hour per kilogram battery, and right now state of the art closer to 400. When you're trying to design these really cutting edge systems with high energy densities, with the level of automation and the reliability, it's hard. It's just hard engineering, and like I said, I think these regulations provide a great paradigm to move forward.
Yeah, the conundrum of AAM or any of these larger aircraft in comparison to SUAS is the value proposition seems to be higher and the investment needs to be higher, but the length of time from which you'll see those returns is not only longer for certain, but more variable and questioning or questionable in terms of what the business model eventually actually will be, right? Is it going to be middle mile delivery? To me, that actually seems like an underrepresented kind of use case in this realm. Small airport to small airport travel on more automated systems versus rich guy from Wall Street to JFK, which is what we hear in New York a lot. We did that in the 70s, I think, and the noise complaint was what got it. These aircraft are quieter, so there is an opportunity to possibly start that up again. But again, how much money are you making off of that versus the long-term investment? So Lilium is, it's sad to see any project that was pushing such innovation to go under, but it's expected to see a lot of these innovative companies to hit the skids before they're able to actually materialize something useful.
Yeah. Yeah, I mean, if I could, if I could comment on some of those comments, VTOL is hard. I mean, designing and fielding any kind of aircraft is hard, long, expensive, right? And when you add vertical flight into it, it makes it even harder. And then if you make it a brand new technology, in this case electric, with no, there were no regulations, that allowed it, things like that. All these things add cost, time, effort. Lilium, they're not dead yet. I mean, they're in insolvency for some of the subsidiaries, or trying to find a path, or trying to find some more funding to go to move forward. So I'm hoping they will be in the end successful. But not everybody will be successful, unfortunately. One thing I did want to contrast with FAA and in Europe with EASA. They came out, so the FAA is a bureaucracy, and it's almost like chaos. All the different fiefdoms and offices, and they said they had the SFAR originally, and it was kind of a Frankenstein document. And I think with some leadership from having an appointed and confirmed administrator, they were able to listen to the comments and bring something forward that makes a lot of sense, we think. EASA had a very different approach. I mean, it was very much working with industry, and two of the companies, the earliest companies, Lilium and Volocopter, had this massive redundancy of, at the time, I think it was 36 propeller or 36 fans for Lilium and 18 propellers for Volocopter. So they really went for this mechanical reliability, mechanical complexity. So instead of 10 to the minus 6, it was 10 to the minus 9th, so 1 in a billion chance of any kind of failure, catastrophic failure. And then when they actually held the companies to that, they all grew in weight, cost, complexity, and that, I think, has been one of the many reasons that EASA, Lilium, and Volocopter, where they've been delayed in actually finalizing and fielding their aircraft. FAA is, I don't actually know the number, but 10 to the minus 6 or 7 or 8. It's, everyone's goal is 10 to the minus 6, because eventually we think we will have thousands of aircraft maybe flying daily. So that is a good goal. It's not mandatory. It's not mandated from the very first aircraft. And I think that's an important distinction, where you see the U.S. aircraft coming now I think it'll be coming to the market sooner, and have a better business case than maybe having so much redundancy.
Chris, what are your thoughts?
Yeah, I was just, from the business side of it is, having a realistic expectation of the timelines of what the FAA can or will do. I think the industry from small to large is sort of littered with companies who mistimed it, right? And that's where I was talking about scalability earlier. Is it's a tough business to make money, and if you can't scale, and the regulation is a huge piece of that. So the sooner we get, and even if it's not perfect, but it's an agreed upon set of rules that we can all work towards and build towards and operate under, and you can improve it over time. But we got to have something in place, because that's what the industry is looking for. That's what the industry needs.
Yeah, clear rules actually in industries like this, especially coming from tech, where my background, where people would fight against the idea of regulation so much in safety critical industries like this. Clear regulation actually leads to bigger business.
Nobody's arguing against the need for it. We just need it.
Yeah.
Everybody understands we need it. We need it now.
That I'll push that back to you actually. In why aren't we further along in drones? Does anybody have any insights into that? I mean, I have my opinions, but I really do feel like AAM just leapfrogged drones yesterday or last week, and a little jealous. Not gonna lie, because I started as a drone person, so I just
personal opinion is really look at the hierarchy of what the FAA worries about, right? 737 stuff took all the oxygen out of the room for a long time, right? Yeah. So that had to be the primary focus. AAM and those companies had a ton of money and were coming in and in the billions of dollars, where the small UAS folks weren't going to generate that level of interest. So I think it's the large commercial, then large, complex, big money AAM, and the smaller UAS in priority has fallen below that. I think it's just maybe a capacity and focus issue more than anything. Personal opinion.
Yeah, capacity and focus is kind of what we were discussing prior, and also just managing the issue. My personal opinion is that there's less people to interact with when you're dealing with larger projects like AAM than each individual drone operator, which was the original scare that I think slowed down some of the UAS regulation in the United States. Mike, what were you going to say?
There are some big players with a lot of money in the drone industry, and you guys know better than I do, but Amazon and companies like that, right? I mean, they had a lot of money, and I honestly, I think after the 2001 and using the predators for attack, people had this bad image of drones, spying on people and being, death, having war connotations, and the Amazon Prime error, that original thing from 2015, I think reset a lot of people's thoughts on what drones are and what they could mean for for the average member of the public. But there have been some big companies, but I think Mark's right that it's many companies versus there's a handful, let's say, a couple dozen that have the wherewithal to actually field, it takes $1 billion, maybe $2 billion to develop a new aircraft and field it, for a passenger carrying or that size aircraft. So it's fewer companies that have, I'd say, bigger projects.
I would also throw the geopolitical thing into it. Some of the largest drone manufacturers, they're from adversarial nations, right? So, how many American drone manufacturers can do the lobby? So Amazon was not really a drone manufacturer. They were proposing to be a drone logistics company. And so how many Amazon level groups are able to lobby, get time in front of the right people, start the right conversations, or even get the attention of the press, right? So it's not always on the FAA. Sometimes the press isn't going to give time to an innovative small drone company that has 100 potential clients versus, oh, Amazon's on the scene, you know. So I think all of those are kind of factors that contribute to it. I still think we should be further ahead. I'm going to throw my hand in there and say I think SUAS does deserve advancement in regulation, and hopefully we'll see some soon that will make a huge difference in terms of BB lost flights, because I think everybody's been holding their breath for quite a long time for that.
Yeah, and at the risk of making a commercial on that behalf, you know, the FAA has put out a couple of briefings what they considering for Part 108.
Yes.
And if I put on my, as an FAA test site lead, and at the risk of channeling my inner FAA, they have asked that everybody in the industry take a hard look at those when that comes up for public comment, and not only comment on the things you don't like, because we're all really good at that.
Yeah, remote ID.
but also comment on the things that we like. But there does seem to be a strong emphasis by the FAA not to throw the baby out with the bathwater. I think as an industry, we should be concerned on whether or not the FAA is going to get that out for public comment before the end of this year, as they've committed to, or early next. I am a little worried about timing after an inauguration when the executive branch goes into a 60 hertz jitter for 10 months.
Mm-hmm.
I think as an industry, we should be continue to push the FAA to get it out as soon as possible, and B, when it is out, recognize that I saw people cheering in the aisles on the first briefing I saw from the industry when the FAA talked about what they're considering for 108. So I do think it's going to move the ball down the field quite a bit. We just got to get it out there.
They do like to drop drone comment rules in or put notice of proposed rulemakings up in December, and it's kind of been the cadence, you know, December, February, between rules dropping and commentaries going up. So fingers crossed. 108 does seem pretty awesome. So excited to see more of it about it. All right, that's it for today. Again, I want to thank our speakers for joining and providing their great insights, our sponsors for supporting the show, and everybody that tuned in today on the live stream. That's it for now. We got Dawn coming up tomorrow with Josh Strange, so check that out. And yeah, lots of other good Dawn of Autonomy shows coming up. So excited to see you all, and we'll see you again soon. For now, we are out here.